If you see the word acidified, or if it just says it, or if you just presume it's a redox reaction, not even if it doesn't say acidified. If it doesn't say acidified, it almost always is. If they want you to think in the basic way, they're going to tell you it's basic. If it's acidified or if it's straight up redox, then you're going to have hydrogen ions as reactants, and water is going to be a product. If you're reacting a metal with oxygen, you're going to get a metal oxide. Non-metal with oxygen, you're going to get carbon dioxide and water oxide of the non-metal and the hydrogen. All right. Let's look at some straight up examples. So I'm on, let's look at problem set number 1. It says 1 at the very top. It should be the first one in your packet. This packet. Yeah, that big packet with all the words on it and all the formulas, that's just for fun. Yeah, that one. So it always is, all of these practice problems are going to show you the exact same setup at the top. So let's look at the first example that we have. We have a solution. Let me write it up here so we can put our attack strategies into practice. I'm going to abbreviate so I don't have to write too much. Okay, so going to our attack strategies. We see a solution of sodium sulfide added to a solution of zinc nitrate. What can I cross off?
The nitrate.
You can cross off the nitrate. It's gone. What else can I cross off? It's good coffee, by the way. Because it's almost gone.
Sodium.
Why can I cross off sodium?
It's a type 1 metal.
Yeah, and it says solution of. So if it says solution of sodium sulfide, sodium is going to be soluble because it's a group 1 metal. It says solution of zinc nitrate. Solution means that the nitrate is going to be soluble. First rule there. Nitrates are going to be soluble. So what's left over? We have our sulfide ion, and we have our zinc ion. And what do they produce? Right? Is zinc sulfide a soluble or insoluble salt?
Soluble.
Most sulfides, rule number 5 on solubility rules, oh well, that's not all, that's the solubility rule on that paper. I didn't bring an extra copy of that, I'm sorry. I'll make a notation to send back to you guys as well. The standard solubility rules has sulfides generally being insoluble. There are exceptions to sulfides being soluble. If your sulfide is combined with group 1, then it's going to be soluble. If it's combined with any other metal, it's going to be insoluble. Okay, and they don't really care that you put any symbology here. You don't have to put AQ, G, S, L. You don't have to put up arrows, down arrows to indicate anything like that. It's just, you know, if you want to, if you're in the habit of doing that, it's not going to hurt you. But as students have learned throughout the years, you can talk yourself out of points. So if you put this as precipitate, that's fine, but what if you drew it like that? You would indicate that the zinc sulfide is a gas, and then that would be wrong. Okay? So make sure, if you're going to use symbology, then make sure you know what you're doing. If not, just leave it naked, and then nobody's going to pay any attention to it. So you get 1 point for this, you get 2 points for this, and then because it's already balanced, 1 sulfur, 1 sulfur, 1 zinc, plus 2 charge, minus 2 charge, so the charges are balanced as well. You get 1 point for the balance. And then let's look at the question that it gives us. What are the spectator ions? So what are the ions that are not participating in our reaction? And you would just have to list them as ions. You can't just say sodium and nitrate. You need to show them as the ions. And you get 1 point for this as well. And they don't care if you put +1 or 1 plus, it doesn't matter. When I was in school, that mattered. They've changed those rules. Okay? This is, if you see a problem like this, this is as easy as it gets. This is as easy as it gets. This is a straight up double replacement reaction, and that may be a question as well. What type of reaction? Yes, then.
I don't understand, like, why do you only deal with the sulfide and the zinc? Why don't you, like, write the sodium nitrate there, too? Like,
Okay, because it's in solution, so the net ionics are showing us what's going on at the chemical level. So really, the reaction that is taking place in the solution. If we included the sodium and the nitrate, they're staying dissolved in solution, so we're not going to notice that they're there. Think about taking two clear liquids and putting them together and having a clear liquid. You wouldn't notice that anything is taking place.
so for, like, these problems, you're only worried about, like, the product that would precipitate out of it?
Exactly. Or a gas that would be produced or water that would be produced. Right. Okay. Any other questions?
Like, would you get points taken out from it if you did write the full double replacement action and just, like, mark aqueous behind the sodium nitrate?
Yeah, you won't get points for that.
Or would it take away points?
Well, it's only positive points. So what you would probably get, you wouldn't get this point, because they want to see that you understand what's going on, what the real chemistry is going on. You would get this point. You'd get 1 point for this. So if you wrote, in addition to this, if you wrote sodium nitrate as a product and wrote aqueous, you would get 1 point for this, but you would not get the second point. You would get the point for balancing, because you have a reasonable equation, so you get the point for balancing. So you have the potential to earn 3 points if you write the full molecular rather than 5 points. Okay? So still, that's one of those situations, if you see a problem and you don't know how to break it down, write what you know, because at least you'll get something out of it. Okay? All right. Next question. This right?
Yeah, you can use that one.
Okay.
That's a new bottle. The other one, I haven't broke into that one yet.
Can you just